Hello, everyone. So today we'll be learning about VEX Robotics, which is the kind of robotics that I do. Today is the intro to it. So this is all just general stuff that you can learn and get started with. So this will be VEX Robotics. So first thing that we're going to be talking about is drivetrains. So basically what drivetrains are the base of your robot, and they're going to be the ones who drive around with it. They have wheels, metal on them, different kind of gears, which we'll be talking about today. So first thing that you can have is a 4-motor drivetrain. In this drivetrain, you will have 1 motor per wheel. You'll have more power for the entire drivetrain because there's more motors. And typically you have to sync the wheels on each side. How you can do this is with 2 ways. You can do it with a gear train or chain. So what that means is that you put gears throughout the wheels so that they can move in sync, or you can put 1 gear on each wheel and then chain them together. So that's called syncing the wheels. And so basically that increases the stability and control of the entire drivetrain. But this is not necessary to use gear and chain because the motors all are connected to each wheel. But it's better to do it usually. Next, we have a 2-motor drivetrain. This one requires less motors. It only has 1 per wheel on each side of the robot. So you'll have 1 on one side and then a gear train or chain that connects one side, and then the other side, 1 motor and then gear train or chain that connects that side. So it's actually necessary to sync both wheels on either side for this robot. So like we said, you can either use geared ratio, like a gear train or chain, and it'll be easier to make space for other materials because the motors won't actually be in the way. So that's helpful. But as we talked about in the last slide, there will be less power because it has less motors. So for a holonomic drive, this is a drivetrain that can basically move in all directions. So we're talking like not just forward and backward or right or left. It can move northwest, northeast, southeast, southwest, all the directions basically. And for this, it literally requires 4 motors because 1 motor is attached to each wheel, and they move correctly in that order, basically. So that's why it requires 4 motors, because each one is specifically programmed in a different way to go a specific direction. So because of that, it's much harder to code than the other 2 drivetrains we talked about. However, there is actually constricted space in this one because the motors are all kind of pointing inward instead of pointing outward. So basically what this one is that you have less space in the middle a little bit, but you can build on top, of course. And yeah. And for this one, as we'll talk about in the next slide, there are specific kind of wheels that are required. They are called omni wheels. So omni wheels, they are really good for speed and holonomics. If you look at the picture over here, we have a full wheel with little rollers on all sides of it, basically. So those little rollers are the reason why they are required for holonomics, because they can, even though a wheel might move in one direction, they can still move because of the rollers in another direction. And then on the right here, we have regular wheels. So these are really good for just traction and grip. Omni wheels, they slide really easily, so they're not really good for traction. So if you really need like good grip to get onto somewhere, to get onto like some kind of a platform or like an elevated area, it'll be a little bit harder if you don't use if you use omni wheels instead of regular wheels. So next we have lifts. So lifts usually go on top of your drivetrain, right? These are not your final thing, but close to your final. And these are basically what goes on top of your drivetrain and basically just helps you gain elevation and helps you do specific actions. So for this one, we have a parallelogram lift. So this one can either be a 4-bar or 6-bar. And if you really want to get into it, an 8-bar, but typically we just use 4 bars or 6 bars. They are really good for controlled and extended reach. So that means that they go up and down really, really nicely. Just enough that what you need, you know, not too high, and obviously just the right amount you need. And these usually require 2 or 4 motors. Typically depends on how much you can spare, but also how much power you really do need. Yeah, so 2 motors obviously will give you a little less of a stronger lift, but 4 motors will give you that really good push that it needs. And many different structures can be added onto it. For example, like over here, they added 2 C channels or 2 pieces of metal on it that you can maybe use to do some kind of action that you want to. And it's very compact because, as in, like, it really folds down like in a very nice compact space in your whole robot. And that's how you'll be able to drive around without like tipping over or anything like that. Next, we have a double reverse 4-bar, also called a DR4B. This one has 2 to 4 motors required. More can be used for greater power. Basically, it requires 2 motors over here. And then if you really want to add some more strength to it, then you can add another 2 motors over here. So how this double reverse 4-bar lift works basically is that it's like the last lift that we talk about, a 4-bar, but 2 of them basically. So here we have the first one. This is the first part, and then these 2 C channels on either side extend outward. Then you have the second 4-bar right over here, and it faces the opposite direction. And these 2 C channels extend outward here. So that's basically how it works. It has one 4-bar that goes like this, and then it has another one stuck on top of it that moves the other opposite direction. So that's how that works. It has a really good extended reach because they're basically 2 4-bars stacked on top of each other. However, it's a little bit of a complicated build because it requires a lot of gear ratios, and many different structures can be added as well. For example, in this one, they actually have a clamp attached to this. So you can have a claw or a clamp that basically attaches onto the object that you want to carry, and it'll be able to do that. And like we said before, all lifts are usually, they need to be compact, right? So this one is very compact. That's why it faces opposite directions. If it faced the other direction, it most likely would tip over due to all that weight in the front. So that's why it's facing the opposite direction, and it folds down very neatly. So you can see it fully extended in this picture over here. So this is, again, we talked about the first 4-bar and then the second 4-bar, and then a structure is added on top. And then next we have a rack and pinion. So this lift basically just moves vertically. The other ones kind of move like outward and diagonal. This one just moves vertically up and down. So generally only 2 motors are required for this one. It's a very simple build. All it really requires is like some gear and chain that basically makes it just like push upward, the whole thing kind of just like revolves, and then it just moves upward. And many different structures can be added to this one as well. You can see here they have 2 claws attached to this one, which is actually much more helpful, right? Instead of just a single one. So it can pick it up at different elevations, which is, I think, really smart. And yeah. Okay, additional required structures. So we talked about before, like claws, clamps, that kind of things. We'll be getting into that. So clamps, here we have. So it's basically like a claw, but it clamps down fully onto the object. So over here, as you can see in this picture, this is the part that like pushes into the object, and then this part here is basically where it just kind of clamps down, so then it just kind of like pushes fully down onto the object, so it just like stays there. And then it is to be added onto a lift. So you can't just have this usually on its own, otherwise you won't get that elevation that it needs, right? So you usually put this onto a lift so that the lift can then move with it, and then this thing can clamp down wherever you need it to. And generally that requires like 1 to 2 motors, depending on maybe how heavy the object is. It's a little bit heavier, then you might want to go for 2 motors. But yeah, clamps are generally a very useful added required structure that you could have. Intakes. So intakes are used to basically just suck objects into a robot. They're made with gears, chain, and flaps, so that when you have them positioned at the end of your robot, they basically just suck in objects. They just turn really, really quickly, and so then the objects kind of just like flush into it. And they're usually used to accompany other lift mechanisms, as in like they're supposed to go on top of lifts. You can't really just have them on their own. And sometimes wheels can be used for intakes as well. As you can see in these pictures here, there are wheels being used over here, a wheel over here, a wheel over here. I really like this design, especially because they have like kind of two different intakes working together. So first the object goes in here and then it's kind of like pushed underneath by this whole revolving thing. It's very, very useful and very smart. And so now we're just going to talk about examples of possible robots that you can build using all the talked about things in this video. So first thing, this is example 1. So as you can see here, it's a very complicated robot, but it has a 4-motor drivetrain. It has a DR4B. So here's the first 4 bar, and then here's the second 4 bar facing in the opposite direction. And then as you can see here, they have a kind of a clamp structure that basically it folds down onto these cubes. So it just kind of like pushes inward, right? So there are 2 motors right about here and here. Basically, they just move outward and in, right? So basically when it clamps down really, really tight onto these objects that you're holding. So a very nicely constructed robot. Next, we have our second example. So in this one, we also have a 4-motor drivetrain, very general drivetrain. It does everything that you need it for. And it has 2 motors for its lift. So for this lift, it's basically just a 4 bar, right? It just goes up and down. That's about it. And it has its its intake on it. It's basically these wheels kind of intake the objects into it, and then they just kind of move up and hold it there. And then you can like move that up and down to where you need to put it. So that's basically that. Yeah, thank you so much. We will have a demonstration in the next video where we will talk about more of the detailed stuff and stuff like that. So just be sure to look out for that. Thank you and have a good day.